Okay, let's continue with another derivative one here. So we have f of x is 3 inverse tan of radical x. Okay, so again, I'm going to think of this as 3 inverse tan of x to the 1/2. So I really have 3 inverse tan of something. So constant multiple 3. Inverse tan, now the derivative of inverse tan is 1 over 1 plus x squared. So it's 1 over 1 plus the something, x to the 1/2 squared, times, go inside, and I need the derivative of the x to the 1/2, which is 1/2 x to the minus 1/2. So I get 3 over 1 plus, so x to the 1/2 squared is just x. And then I have 1/2 x to the minus 1/2. So you might see this something like 3 over, I'll put the 2 there. I have a 1 plus x, and the x to the minus 1/2 from the top could be a radical x in the bottom. All right, let's go on. Find dy dx given x squared y squared plus x sine y equals 4. Okay, so we want a derivative. We still want dy dx. The difference is that because of the y being in there, the y is implicitly defined in there, so we're going to have to use implicit differentiation. Alright, so I'm going to do the derivative with respect to x, both sides. Okay, so when I do the derivative of the left side, when I get to x squared, y squared here, realize that's a product. So the derivative of the first, 2x times the second as it is y squared, plus the first as it is x squared times the derivative of the second, which would be 2y dy dx. Alright, so all of that is coming out of that first part, plus now when I go to the x sine y, that's also a product. Derivative of the first is 1 times the second as it is sine y, plus first as it is x, derivative of the second cosine y dy dx. Alright, equals 0. So this whole part was coming from there, and this is the 0. Alright, so all the derivative taking is done. Now I need to clean this up and get dy dx isolated. So I have 2xy squared plus 2x squared y dy dx plus sine y plus x cosine y dx is 0. Alright, I'm going to leave these two terms on the left. Alright, and move the other two terms to the other side, so I get a minus 2xy squared minus sine y. Now I'll factor the dy dx out. 2x squared y plus x cosine y, and the right hand side stays the same. And then I'm simply going to divide what's in the brackets over to the other side. X squared y plus x cosine y. And there we have it. Okay, what's next? The classic equation of the tangent line. All right. So find the equation of the tangent line to the curve at the given point. All right, so we have this curve here, and we're told we want to do it when x is 0. Okay, so two things here. First, we need to talk about what the point is that we've been asked. So they've only given us the x value, but that's okay, because for x is 0, y would be f of 0, which would be 0 plus 3 over 2 times 0 plus 1, which would be 3. Okay, so our point is actually 0, 3. So that's how we get the y coordinate. So now, if we want the equation of the tangent line, we're going to need the slope and a point. Well, we already have a point on the tangent line, that's 0, 3. The slope, that's going to come from the derivative. So I need the derivative. So there's a quotient rule. So if we're looking up here at the x plus 3 over 2x plus 1, derivative of the top is 1 times the bottom, 2x plus 1, minus the top as it is, x plus 3. Derivative of the top is 2 over 2x plus 1 all squared, the bottom squared. That's going to give me 2x plus 1 minus 2x minus 6 over 2x plus 1 squared, which 2x's cancel. 1 minus 6 is minus 5 over 2x plus 1 squared. Now that's my derivative at any x value. I'm not looking for it at any x value. I'm looking at for x equals 0. So f prime at 0 would be negative 5 over 2 times 0 plus 1 squared, but that's just going to be negative 5. So I pretty much have it now. I have my slope, m of negative 5, and I have my point, 0, 3. Now I could use point slope form. So y minus y0 equals mx minus x0. So y minus 3 equals negative 5 x minus 0. Y minus 3 is negative 5. And so we get y is negative 5x plus 3. And there's my tangent line. Done.